Welcome, fellow explorers, to the fascinating world of chemistry. Chemistry is the study of matter and its interactions. Our journey begins with atoms and molecules. We'll explore atomic structure and the periodic table, witness the magic of chemical reactions, discover biochemistry and the symphony of life. Let the exploration begin. Our universe is constructed from matter, and at the heart of matter lies the atom. Atoms are incredibly small particles, so tiny that millions of them can fit across the width of a human hair. Imagine an atom as a miniature solar system. At its center lies the nucleus, a dense core containing positively charged protons and neutral neutrons. Whizzing around the nucleus are negatively charged electrons, much like planets orbiting a star. The number of protons defines an element, giving it its unique identity. Elements are the pure substances that make up the universe. Each element has distinct properties that determine its behavior. When atoms share or transfer electrons, they form chemical bonds, the glue that holds molecules together. Understanding atoms is key to unlocking the secrets of chemistry and the universe itself. Imagine a grand library containing all the known elements, meticulously organized based on their properties. This library is the periodic table, a masterpiece of scientific organization that has become an iconic symbol of chemistry. The periodic table arranges elements in rows and columns based on their atomic number, which represents the number of protons in an atom's nucleus. As we move across a row, called a period, the elements gradually change in properties. Columns in the periodic table, known as groups, contain elements with similar chemical behavior. This similarity arises from the arrangement of their outermost electrons, known as valence electrons. The periodic table is not merely a static chart, it's a dynamic tool that helps us predict the properties and reactivity of elements. By studying the periodic table, we unlock a deeper understanding of the elements that make up our world. Section 4. Chemical reactions, transformations of matter and energy. Chemistry is a dynamic dance of atoms and molecules constantly rearranging, breaking and forming bonds, transforming matter. These transformations are called chemical reactions. Imagine baking a cake. You mix flour, sugar, eggs and other ingredients. Baking causes a chemical reaction, transforming raw ingredients into a delicious cake. Reactants transform into products, breaking and forming bonds. Some reactions release energy like burning fuel, others require energy like photosynthesis. Understanding chemical reactions is crucial for developing new materials and sustainable energy. Section 5. The chemistry of life, biochemistry and beyond. Life is a symphony of intricate chemical processes, each molecule playing a role in maintaining balance within organisms. The central dogma describes the flow of genetic information from DNA to RNA to proteins. DNA carries genetic instructions, RNA acts as a messenger, and proteins perform various functions. Biochemistry has practical applications in medicine, agriculture, and biotechnology. Section 6. Exploring the cosmos from nuclear reactions to astrochemistry. Our journey through chemistry extends beyond Earth, reaching the stars. In stars, nuclear reactions forge heavier elements from lighter ones. Stellar nucleosynthesis creates elements like carbon and oxygen. Astrochemistry studies the chemical makeup of celestial objects. By analyzing light, astrochemists identify molecules and chemical processes. Discoveries like organic molecules in interstellar clouds suggest life's building blocks are common. Water ice on Mars hints at possible life beyond Earth. Astrochemistry expands our understanding of the cosmos.